Hello, everyone. So this is part 3 or episode 3 of the ETABS API tutorial. This is a follow-up to the last one where I kind of covered just the basics of how to connect to ETABS using Python and the basics of Python itself. In this video, we'll go over the API notation, setup, connecting to ETABS, setting up material sections, cases, combinations, that kind of thing. Creating elements, and then running the analysis and extracting the information. So this video will just be a very general and basics of the API and kind of understanding how to read the documentation. And then in future videos, I'll go into more depth and actually creating a full-blown application or a plugin with both just a command line interface, user interface, and also a graphical user interface. And also, if you have any suggestions for future content of what you'd want to see, what you want to learn, feel free to just send me an email or message in the YouTube comments, or go to reframeinc.com, and you can find my email address there and let me know what you would like to learn. Because right now I'm just kind of going in order of what I think is the most important. But I've been getting emails of other suggestions. So I'll be doing that content and whatever else you would like to see. So to get started, I have the PyCharm IDE open. You should already have that installed. If you don't, check out video number 1. I also have ETABS open here. And so what I'm going to do is I'm going to actually write code in the Python console itself, rather than writing a script and then just running it one time, because we're going to be doing things in order, and I don't want to run a whole script. That way you'll be waiting till the end to see what we've built. This way you'll be able to kind of follow along and see what's happening. And then again, in future videos, we'll go into an actual user interface and things like that, so you can actually interact with the code. So over here in the Python console, we're going to type in our initial import statement. So we're going to import comtypes.client. And actually, I'm going to go ahead and open up or create a new ETABS program or a model that we'll be connecting to. So it'll be a blank one. It's going to overwrite an old one that I already have. And this example is going to be very similar to the Python example found in the documentation, but it's going to be a little bit different, a little bit just kind of focusing on the main stuff that I think is important. But once you follow along with this tutorial, you'll be able to understand exactly everything that's happening in this Python example. Okay, so we've imported the comtypes client. That's a library that we need. Then we'll go ahead and type in ETABS object is equal to get active object. And then here we're going to find the CSi program. And this is all the same as the documentation. So this here is going to use comtypes, which is like a .NET framework or like a Windows operating system library that lets us communicate with the ETABS program. And then it's going to get the active object, which is ETABS. And this is just what CSi is calling their object. and it's going to assign it to the ETABS object. So let's make sure everything is spelled correctly, and then hit enter. Okay. And so you can see here that we got the object, and it has a bunch of properties and values. And see this SAP model here. This is what we're actually going to be interacting with. This ETABS object is the entire program. SAP model is the actual model that we're working on. So we want to work with this one here. And so what we'll do is we'll conveniently just call SAP model is equal to the ETABS object that I have here, the variable that I was assigned to here, and then dot SAP model. So that's going to take this SAP model and assign it to just this SAP model variable. That way we can directly then just call on this to do our functions and make our program. And this is basically the object with a parameter. And then we can then invoke the methods that are attached to the SAP model. And if you have no idea what the heck I'm talking about, go back and watch the previous video where I explain classes and methods and instances and things like that. So I'll go ahead and hit enter. And so now here we can see that we have a SAP model variable, and it's something in memory. And you can see it's got all this different methods and parameters and stuff like that. But we're not going to really be interacting with anything over here. This is just to kind of get an idea of what's happening in the background. And so the next thing that we're going to do is going to make sure the model is unlocked. So SAP model dot set model is locked, and then going to type in false. And this is something that you want to just make sure you do so you can actually then interact with the ETABS model. If the model is locked, then your API commands may not do anything. Like you can't add a frame or a material or whatever if your model is locked. So if I hit false, and then it went and returned a 0. So by default, a return 0 means it was successfully returned. And so you can see here that it's unlocked. If I were to go ahead and call the same functionality again, and I brought that command back by just pressing up on the arrow key, but let's say I change that to true, and I hit enter, I got a 0 return again, and then you can see here that I locked it. So that's how I'm interacting with it. And so yeah, you just press up to call the previous command so you don't have to type it all over again. So we're going to go ahead and unlock it. Okay, so now we can go ahead and interact with it. So unit preferences, that's the next thing. So we're going to go ahead and create a variable, and we're going to call it Newton millimeter Celsius, and that's equal to 6. And we'll go ahead and do SAP model set present units. And we can either type in 6 directly, or we can set in the variable that will be created above. And so what this is going to do, it's going to use the default or generic metric system for our ETABS model. I think the imperial system needs to be abolished, so I'm not going to use the imperial system. We're going to go ahead and use this, but you can use whatever you like. And if you're wondering where the heck I got this 6 from, basically it's from the documentation. So if I were to go and look up that command, so it's, what was it? Set present units. So you can see here, the set present units takes something called the E units, and here you can basically find the enumeration constants. So if you want to go ahead and use like Newton millimeter C, um, that's number 9. Sorry, I'm using number 6. That's kilonewton meter C. So I'm using actually this one here. So I got the wrong one. But anyways, I'm going to be using uh, number 6 here because then I'll be working with in kilonewtons meters in C. So I'm going to go back and fix that mistake. So I'm working in kilonewtons, millimeters, and Celsius, and that's number 6. This has no effect on the actual code because I punched in like the value of 6 and either way, so it doesn't matter. And so the next thing that I'll be doing is setting up some materials. So if I come over here, define materials, I just have the generic material properties that are given to me in the template. I'm going to go ahead and add some of our own. So that's SAP model, and then we will do prop material. Set material. And then here I'm going to type in the new name for it. I'll call it concrete 35 as in 35 MPa. And then the value of 2. And so where I got that from is set material. So here, this set material command essentially wants, this is what you use to create a new material. And it wants a few different arguments for the function or the method. And so in a string format, it wants a name. Then it wants that enumeration. So that's an emat. So this is basically an integer. And you can find that by clicking on this. And then it'll want optionally an integer for a color, a string for notes, and a string for basically a global unique identifier. And how do I know that these last 3 are optional? You can see that here. So it's colors optional, notes optional, and the GUID is optional. So when I basically typed in that command here, I left out the other 3. So what's happening is the program is using default values. So if I don't want to give it a color, special notes, or a unique identifier, I don't have to. But these ones here, the name and the material type, those are required. And so, for example, for material type, I had put in a value of 2. And so how do I know that? I click on this here and look at the documentation. And for concrete, it's a value of 2. And so if I come over to the ETABS model and I go to define material properties, I can see that concrete 35 was added. And if I look at the properties of it, the modify, you can see here that the color was done by itself. I didn't pick it. And then for modify notes, there's no notes in here, but I could have added notes if I wanted to. And so the next thing that we're going to do is we're going to define the detailed material properties. So if I go to here, there's a bunch of detailed information, essentially like all of this here that I'm going to assign. Here requires, again, like a name, a concrete strength FC, whether or not the concrete is lightweight, an FCS factor. So if it is lightweight, then what is the reduction factor? So for example, if you had like lightweight concrete, you have a shear strength reduction, so maybe 0.7, for example, and a bunch of other things for the hysteresis type, the strain, and all that. And you can see here what those values would be. But basically, it's a string, a double, which is basically a decimal number, takes up twice as much memory as a float, but that's not important. A bool, double, integer, integer, double, and these are all doubles. So then when I go ahead and type that in, it'll be SAP model, prop material. You can see that the program it's auto-completing for me. Set O concrete. And then here, I'm going to reference the material that we had just created above, the same name. And that's going to be 35 MPa because we're working just in metric. It's going to be false for lightweight. And then these other values for the type, the hysteresis, and all that kind of stuff. I'm just going to quickly fill that in. So 0, 1, 2, 0.0022 for the strain. And again, you don't have to do this from like programmatically. You could just go ahead and define this in ETABS, but I want to teach you how to be able to use ETABS without ever having to interact with the actual user interface. That way you can automate a lot of tasks. So you can see here, I put in all the arguments, and these arguments have to be the same format as this here. So these are all like doubles. Technically, this is an integer, but that's okay. That's not an issue. But for example, this first one here is a string. So you have the quotation marks, and so I have the name there is a string. And so just as to double check that we've entered in everything, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 arguments. And then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arguments. So I'm off by 1. Oh yeah, sorry, temperature is optional. So we're not going to put that in. So actually, yeah. So there's 12 here, but the last one is optional. Can go ahead and leave that out. So yeah, so 11, 11. I'll go ahead and hit enter. Oh, I got a 1. So I didn't do that correctly. I made a mistake. What did I do? Oh, I have the wrong command. It's set O concrete. There's an underscore 1 here. Got that wrong. So go ahead and type in. Press up to get the previous command, and then set O concrete. Put a 1 there. Did I get it? Yeah, there you go. I got a 0. So now if I come over to ETABS and go to define materials, I take a look at this. Now it's going to have the values that I put in for that I had punched in. So it's got 35 MPa there, and these other values of 0.2 and whatever. I'm not going to get into all the little details right now. It's not important. So the next thing that we're going to do is we're going to create some sections. So if I go here, define sections, frame sections, I got a bunch of generic ones or whatever comes with it. I'm going to create my own just because I need to show you how it's done. And so for that, we'll go SAP model prop frame is the command, set rectangle, and then I need the section name. And so I'll call it just concrete section because I don't have any imagination. And what else does section name require? So I'm going to go to or set rectangle require. Come here, set rectangle initializes the solid rectangle frame section, so it needs a name, material property. T3, T2 are the dimensions and those things, and the rest are optional. So I'm calling it concrete section. The material that I'm using is going to be concrete 35, which I created before, and then the dimension. So the dimension along the third axis, so that's the width, and then 2, 400, and the other ones are optional. Enter, got a 0 response, so it went through, which is good. Define section, and then you can see here concrete section. I just created this here. I go to modify, I can take a look, and I got 400 by 400. That's what I just created right now. This rebar here is put in by default by ETABS. I didn't do this, but you can go ahead and change the rebar layout. There are commands in this. I can look for it, but I'm not going to mess around with this right now. But yeah, you can type in, like here, I can do this command, and I can set the rebar, and you can put the number of bars, the cover, all that kind of stuff. So this is really useful if you use your own design module, or if you have like the program Afterburner column. It basically does a design, and then it inserts all of these detailing information in, and then this is all set up for that. But we're not going to get into that right now. I'm trying to keep it a little bit high level. So the next thing we're going to do is assign the load patterns. And so that's done by using the load patterns command. So that's this one here. See if I can find it. It's a bit of a pain in the butt to go through this sometimes and find, or the add method. Okay. Yeah, you're gonna spend a lot of time going through this this API. I've spent countless hours, maybe I don't know, I've lost track, but I'm sure I've spent days and days of my time just going through this, reading it, trying to understand it. But then once you get familiar with it, then you kind of know what to search and stuff like that. And if you are having difficulty finding stuff, feel free to just send me a message and I can help you go through it. So I'm going to use the add method. And so it requires the name, the type, and then you have some other stuff, which is optional, like a self-weight multiplier and stuff like that, which I'm not going to get into. So for that, it'll be, again, SAP model dot load patterns, and then it's a add. So what I'm typing in here is basically this part here. So it's the dot add, or you can look in this example here. See how that SAP model dot load patterns dot add. It's the same thing. So dot add, and then we're going to add two cases. So L case 1. I'm calling it, it's a pattern, but I'm calling it a case. Oh, so yeah. A number 2 value. So that's this enumeration type. So it's going to be a dead load or live load. You can go through the documentation to see what's what. And then I hit enter. So it's good. That went through. And then I'm going to create another one. This one is load case 2, and this will be a number 3. So it's a live load. The first one was a superimposed dead load. That went through. And let's go to ETABS and check our work. Always check your work. Make sure you're doing things properly, step by step. If you rush things, you'll end up having to go back and fix it. It'll be 3 a.m. and you're debugging and your wife is yelling at you. L case 1, L case 2, so super dead. And then like dead load here, that would have been a value of 1 if I had put that in, but I didn't. So it's not. Okay, now load cases. So you have to define patterns and cases. Yeah, it's a bit tedious, but we're going to automate that so then you don't have to do it manually anymore. Static linear set case. That's going to create a case from the load pattern that we created above. Now we're going to do the same thing for this. So we got a 0 response, that's good. Check our work, define cases, and so you'll see case 1, case 2 is there. And now we're going to create some combinations. So right now we don't have any combinations. And for this, it will be, so to create a combination, the command for that is going to be, it's under response combination. Adds, I think this is what I'm looking for. So here the command you type in SAP model dot response combination dot add, and then it's got a name. Yeah, so we're going to create a name, and then it's got this value here. So, oh yeah, so that's if it's the combo type, so that's a 0 for linear additive, 1 for envelope absolute additive. That's, what is that, square root of the sum of the squares or whatever, range additive. We're going to go ahead and just use the good old linear additive. I'm a simple man. So for that, it will be SAP model combo, and then we're going to add, and we will call it combination 1. Let me check something. I wonder if I have this open, will it talk to it? Will it just show up in this? No. Oh wait. Oh, I missed. Oh yeah, the combo. See, type error, required argument, combo type is missing. So that was the second argument, this combo type. So we need an integer for that. I forgot to put that in. So it was a 0 that we're going to put. But I want to see if this auto-populates. So I got a 0 response, but it didn't show up here. So if I go define combinations, oh, it's weird. It's not showing up. Let's try that again, but this time with the window closed. Oh, okay. So yeah, you can't have this window open when you do it. It has to be closed. I knew that. And so right now there's no cases in here. Let's add those. I apologize if this is really slow and tedious, but it's just the nature of going through it step by step. The dead load will put 1.25. That's Canadian convention. Okay, got a 0 response. That's good. Here we got an array response. So the last one is the return, so whether it's successful or not, and then the first one here just tells me basically some other information about what I just did. So if I go to set case list, response combination, it returns two things. Um, return 0 if the item is successfully added or modified. It doesn't tell me what that other, this 0 means. That's okay. Oh, I think, it's going to repeat the type back to me. But yeah, sometimes you get an array back, sometimes you just get a single value back. That's okay. And then we're going to add our load case 2 that we created, and this time that'll be a 1.5. And that looks right. Hit enter. And if I come over here and I check my load combination, I go to modify, and voila, got load case 1, load case 2, 1.25, 1.5. Sweet. And it's linear additive. We had those options before. Okay. Okay. So the next thing that we're going to do is we're going to check if we added everything correctly. So this is going to be a get case list. So we're just going to get the program to print it out to see if we got everything. So this get case list just retrieves all load cases and response combinations. We don't have to do this right now, but I thought I would just show you a get function so you can retrieve information. So this just wants basically a name, and then you can see here how these ones have an ref in front of it. So this is something from C#. This is not a Python thing as far as I know, so correct me if I'm wrong, but in C# you can do something called pass by reference, where you create a variable and it can be empty, and then you pass in that variable as an argument, and the program will then assign the value, like what the function that you call will assign that value to that value in memory and give it back to you. That's not the case here. With Python, you'll have to assign those values like the standard way, return from the function call, and that will basically, those variables that you get, you can then assign them to variables. If that doesn't make any sense, we're going to get into the details of it. But basically, this whole ref thing, what you need to know for this is it wants variables to be put in, but they don't really get used. It's like a C# thing. So we're going to go ahead and create like dummy variables to pass in, but then they don't get used, if that makes sense. Yeah, it's a C. Yeah, for example, I think these are all passed by reference. Okay, so what I'm going to do is I'm going to create a number items variable. You can call it whatever you want. You don't have to call it this, but I'm going to just stick with it. So a number items value of 0, a C name type, and this I'm going to make it into an array. See how that has this open and closed square bracket? So I'm going to create an empty open and close square bracket. It does care about the type. If you put a string in here or just a number or whatever on its own, it'll throw an error saying it has the wrong variable. Because in C#, you actually assign the data structure type to the variable when you initialize it. In Python, you don't. Python is loosely typed. It's not strictly typed like C#. Okay, so now that I initialize these dummy variables with the correct um, data structure, then I can call that function. So SAP model response combination get case list. So that's basically this command I'm just pulling from here. And then inside of it, I need to put in the combination. So this actually does matter. I'm going to put in combination 1. That's what I want to get the cases for. And then I do number items, CNAME, type, CNAME, and SF. So these here have to match this here. So you don't want any spelling mistakes. Otherwise, it'll say it and get a value. Okay, so that looks like it went through. Yeah. Okay, so I got the 0. So the last item in the array is a return. A 0 means it was successful. If it's non-zero, then you got an error. So sometimes when you're writing like a long program, like a big program, what you'll want to do when you do a command that gets something, you want to check the last value and see you got a 0. If you didn't get a 0, then you know to halt your program or throw an error and notify the user so they don't continue with the program because it's not working properly. And so here the 2, that's so what I got back the number of items. That's the number of cases. 0 here means the type. So these are both load cases. They're not load combinations. So I don't have load combos within my load combos. And then CNAME, yeah, then scale factor. So this is a 1.25 and the 1.5 that I assigned. And then, yeah, the 0 is a return type. So that worked out. I didn't have to do this step. I'm just showing you how to use a get function. Basically, it boils down to set and get the whole API. Okay. Now we're going to go ahead and create some frames. So we will add the frames to our ETABS model using the frame object and add by coordination or add by coordinates method. And so if I come over here, add by coord, that's a link object, frame object, and area object. So I'm using frame objects. And so yeah, it wants a double values. So they're just decimal values, a string, and then the prop name and the username. I'm guessing some of these are optional. Yeah, optional. And so I want basically X, Y, and Z coordinates for the beginning and the end. And then the frame name that I type in, it's going to be the same thing with basically like this reference string here. The frame name is a dummy variable that gets passed in by reference, but since we're not using C#, because this documentation is for C#, this doesn't quite apply to us, but we do have to create a dummy. If I'm wrong about that, somebody please correct me if there's a way to have that automatically assign or do a pass by reference. So here we're going to create frame name 1, dummy string, frame name 2, because we're going to be adding 3 frames. So we're going to do frame 3. Okay, and so now let's go ahead and add our frames. So we go good old SAP model dot frame object add by coord, and so this here will be 0, 0, 0. So that's just the origin, and then it's going to be 10 meters tall. So see these values here, I put in 10, and so I'm working in meters. I think I'm in the right units. I think I'm in the right units. But here I have millimeters. Yeah, let's see what happens. I think it's initialized to be in meters. Because I think these millimeters up here are for the section definitions. They're not for this frame stuff. Could be. We'll find out. Frame name 1, and then we have our section name. So the section that we created above, what was it called? It's called concrete section. Concrete section. And then we're going to call it number 1. And then it's going to be global. And these last values here, they can be optional. I don't need to put these in. So you can see here, this is a coordinate system. We're using a global one. If you leave it, if I didn't have this argument in here, ETABS would automatically assign it. Number 1, that's just, I'm forcing it to have that ID, but I can put in, or I can leave it out and ETABS will do it on its own. And then concrete section, that's also optional, but I want it to be a certain value. And you can see I have single quotes and double quotes. That's not a big deal. Okay, so if I run this, it's going to create the section and it's going to give me a return of the, so it'll give me a return of whether it's successful or not and the section name. And I want to go ahead and assign that to a variable so I don't have to go back and get that value manually after. So frame name 1 and then return. So what's gonna happen is when this command runs, it's gonna send me an array back with a return and with the frame name. And that name will be corresponding to this one here, I think. Or actually whatever it decides to give it. No, the program will actually pick. Yeah. So if I hit enter, if I type in print return, so it ran correctly, this variable here. And then if I type in print frame name 1, yeah, okay, so I got a value of 1 because there's no other frame in ETABS. And is there a frame added in here? Well, there is a frame. But why is it so small? Is that because I don't have the right units? Oh no, it's too big. So I clearly am not operating in the correct units. Thought I was working in meters. No, something else is happening. Oh, actually, no, I'm working in millimeters, and I think that value of 10 is 10 millimeters, so it's really small. I think that's what's happening. Because it is there. There is a frame there. Okay, I think I'm in the wrong units. So, you know what? I'm just going to go over here. I'm going to cheat and go to metric SI default. And I'm going to go ahead and just delete. Okay. Now there's no frame. And I'm going to rerun that command. If I hit enter and do a print on the return, did I get a 0? Okay, it made the thing. Something weird is happening. The frame is selected. I think it's making it really small. Yeah, it's making it really small. Geometry. Yeah, okay, so I'm in the wrong units. I want to be working in meters, not in millimeters right now. ahead and delete that again. Let's go back to set present units. Kilonewton meter Celsius is number 6. So let's go copy that, put it over here. Number 6, right? Type in 6, got a 0. And then if I rerun that command, hit enter. Oh, there we go. Okay, we got our section. So we got our frame here. It's got a length of 10 meters. Okay, now we're in the right units. So much for metric being simpler than imperial. Okay, so now let's go ahead and we'll add the new frames in, but I hope this is clear that when this is run, it's returning an array, and then we're automatically assigning those array values to frame name 1 and return. You can do it this way. You could also, for example, you could do something like frame name 1 is equal to, and then have this command up here. Actually, you know what? I'll do it the other way for the second frame so you can see. If I do frame name 2, and I'm going to add different coordinates for this one. If you try to add a frame in the exact same location, it might throw an error. This one's going to be at 10, and then that's going to be an 8, and that's a 16. And I'm going to call it number 2. Okay, so here I want to just call it, assign it to frame name 2, but I'm going to get a return of an array. So frame name 2 is going to end up being an array with the return value inside of it. So what I can do is on this command, I can actually put square brackets to index the value. And I can put 0, so index 0. If I put a 1 here, that'll be this return, but 0 will be the frame name. So we're going to do that and hit enter. And so there you go. Got my second element. Look at that. And then I'll do the next one. Frame name 3 is equal to just going to copy and paste it because I'm lazy. It's a 0 value again. Oops. The one time I do copy paste, I get an error. Oh yeah, it's being lazy. Section name is not defined. Let's try that again. And here, section name. Oh wait, no. Section. Did that work? Sweet. Okay. All right. So I got my sweet little canopy thing, I guess, or whatever the hell this is. All right, what's next? So now we're going to go ahead and assign restraints. So for that, we will go ahead and create some variables. First, point name 1 is equal to nothing, and point name 2 is equal to nothing, or a blank string, shouldn't say nothing. And then we will go ahead and create a restraint array. And so the reason why we're doing this is to make it a little bit clearer what we're up to. So the restraint array is going to say what is fixed and what's not fixed. So we're going to fix it in the X, Y, and Z direction for translation. Then we're going to fix it in the about the X axis in rotation, but about the Z and the Y, it will be free to rotate. So restraint is set to be this array here. And then we will go ahead and use a set restraint command. So you can see here it needs a string, and then it would like to have this array. So yeah, so it's translation about axis 1, 2, 3 and rotation about 1, 2, 3. So set model dot point object set point object dot set restraint, and we're going to put in point name 1, and then we're going to type in restraint. So I could have typed in this array directly into here, but this is just cleaner code to type it up first and then pass that through. Because you can see here, it wants an array of Booleans. So Boolean is true, false. That's an array. So that's how you know what you need to pass through in case you didn't look at this, this documentation. So this tells you the type, and this tells you whether it's just a single value or an array or a list or whatever. Hit enter. And so it returned back to me what I did, which is what I said to do, and then 0 for return, so it worked. If I come over here, then this will be to the correct one, I guess. Is that what I wanted? Doesn't look right. I should have a, this should have been restrained about the, about the R1 axis. Right, but this is for point name 1. What's point 1? We don't have a point 1. Oh, sorry, I missed an important step here. We're supposed to get point name 1. We have to get points first. That's what this command here. Point name 1, point name 2, and the return. It's frame object get points. So from the frame, the frames, we're going to get these values. So the reason why I didn't do anything is because I didn't have the right name. So I'm going to hit this run, and then now I'm going to set restraint. There we go. Okay, so yeah, so this one here now has a UX, UI, UZ, and an RX restraint. Or else give you guys the code so you can follow along with what the heck I'm doing. Okay. And so the next step is we're going to go ahead and assign forces to these two points here. And we're going to create a a value 1, and it's going to be a list. So it's going to be forces in the X, Y, Z direction, and then moments in those directions. So it's going to be 100 and 0, 0. So we're working in kilonewtons right now. So they're kilonewton values. So it should be 6 things in total. So yeah. And value 2, 0, 200, 0, 0, 6 values. Okay. And then we're going to go ahead and assign those forces to the points. And so how we do that is we use set load force, and so that wants the name of the existing point object, and then we will the load case or pattern that we're going to assign it to the value. So that's going to be our array, so value array that we already created, and then bool replace. So if it's already got a value, are you going to replace it or add to it? And then you can same thing about the global and local coordinates. Okay, so that will be done with SAP model point object set load force. That's going to be to 0.4 load case 1, the value array that we have above. It's going to be true. We're replacing if we already have something. Then global. These are optional. Okay, so I went ahead and assigned it. We come over to ETABS model. We should see display, load assignments, joint, and load case 1. Wait, where the hell is it? Got the wrong names. I just assumed it would be number 4, but it wasn't. So this is this unique number 8. Oh, it's because I created columns and deleted them. And this one is number 7. So 8 and 7 is what we want. So I had the wrong point names. That's what you get. Oh, see, if I could use these point names up here, then I wouldn't be making these mistakes. But so let's go ahead and put in number 7. So I come over here and go to display, load assignments, joint, load case. Oh, there we go. So we assigned it there, and that was number 7, and we put it to number 7. Okay, and then we're going to do that one again, but this time we'll do load case 2, and it'll be value 2 and to point number 8. Enter, display, load assignments, joint, load case 2, apply. Voila, it's right there. So you can see 200 kilonewtons applied there. Okay, we're almost done. Now we're going to just save the model because we don't want to have to do this all over again. Or maybe we already did, but I never recorded that one. Or posted that one, I should say. You never know. So we're going to create a model path variable. It's going to be at the C drive. I'm putting double slashes this is convention. If I do forward slash, sorry, it's not convention, it's just the way escape characters work. Forward slashes don't seem to work. For some reason, I was getting an error. So backslashes, but to do a backslash, you have to use an escape character to make it work. I forget the exact details of that, but since we're inside a string, that's just how it works. And then we're going to go ahead and find the location of where I've saved this model. Desktop. Make sure everything is correct and case sensitive. This is called tutorial 3, and it's really important to type in the file type. You're going to need this .edb. If you don't have it, it won't work. And so that's the model path. I think that's correct. And then we're going to go ahead and do SAP model.file.save and type in model path. So then it's going to go ahead and save it to this here. And boom, 0. Nice. Okay. And so the next step that we're going to do is we're going to run it. So at SAP model.analyze run analysis. And so you can see over here, it's doing some cool stuff. Sweet. Sorry, brand. So the next thing we're going to do is we're going to deselect all of our load cases and combinations. You're asking why? Why are you doing that? It's just a good habit because if you select something from a previous step, ETABS won't automatically deselect it, and you don't want to get load like results for combinations that you didn't intend to. So this here just makes sure that everything is deselected. And so if I just grab this, just to show you where I'm getting it from. This here will just deselect everything. And then I hit enter. Oh, no. SAP model results dot. What happened? Oh, no. Okay. It just returned back to me some method. So something in memory. I think it's fine. I'll copy and paste it from here and just. Yeah. Okay. So it did run. So deselected everything. And then now I'm going to actually select the combination that I want to see the results for. Since we only have one load combination, I can only check for one load combination. Set selected for output is combination 1. And then we want to retrieve the information. So we want to get the frame forces. You can get a bunch of different stuff, whatever you want. Also, some things are available through regular commands like this, and some things are available through the tables. We'll just do frame force. So here, reports the frame forces. It's got a bunch of stuff that it needs by reference. So it needs a bunch of arrays initialized, an integer, a enumeration value, and then the string of the actual, the string of the line element that we're going to be pulling from. So I'm going to go ahead and just copy and paste it to save some time. Will that work? Looks like it worked. Okay, yeah. So I created all of these empty values here. And then if I do SAP model dot results dot frame force, and then I'm going to cheat again. I didn't copy and paste. So I'm just going to get it for frame name 1. Expand this so I can see everything. SAP model results frame force, frame name 1, and all of this is just the dummy variables that I have above. And then I can hit enter. Oh yeah, there you go. That's weird. Why did it not give me values? It should have. Hmm. Let's go over here and check if we actually do have values. Combination 1. Oh wait, something is wrong. Something appears to have gone wrong in my steps. Okay, so what I'm going to do is I'm just going to go ahead and rerun my script. I'm going to create a new model. And file, save as. Okay. And so I have this here from before. This is what was my notes that I was taking stuff from. This seemed to have worked before just fine. I think maybe along the way when I was doing the steps, I screwed something up. So what I'll do is I'll just have this script. It'll be in a link in the video, so you can, a link below the video, so you can just grab this and test it out. So if I hit run on this, so that looks like it ran just fine. Yeah, okay, that worked. Okay, so if I go to, for example, yeah, okay, there you go, that's working. I think it is, since it's it not being a solvable structure. I think I have rotation about the z-axis and have a force in that direction. So I think there is actually an issue with this model. But anyways, so it runs, and what you can see here is in this last command here, when I run the frame force and then the return, it's basically printing out the results. So there's two results. And so you can see here that it printed out the forces. And so this is so how to read this. Basically, you have your object station, and then you have your element station, load cases, and then in this order, axial load, shear, torsion, moment. So for example, these are your axial loads, your shear, other shear moments, and then torsion, and then moment about 2-axis, and moment about the 3rd axis, and then the return value there. And so this is giving combination 1 twice. I'm not sure why. So here it's giving me for this value here and this value here. So this is 1, 2, 3. The third argument. The third argument in here is 0, 1, 2, 3. The object. Uh, 0, 1, 2, 3. Sorry, 1. Starting from here, reference. So that's number 2. Is you can see it's kind of confusing. The value 2. Here's number of results. This 1, 1 is your object, and then your station. So object station at 0, and then at 0.002. So there's two different stations on this object, and you can have multiple stations. So you can add more or less to your frame, and you can print it out all along the way. Okay, so with that said, that's the end of this video. I tried to keep it as raw as possible, kind of guide you through the steps, and then also just debug along the way and not have a super clean video, because then you won't get to see basically the steps of like how to find the errors and fix them, because that's what programming is a lot about. It's debugging. When you're programming yourself, you're going to be running into issues all the time. At least I do, as you can see. Um, so hopefully you found this video useful. Please send me more suggestions of what you would like to see. And then in the next video, we'll go into actually writing a plugin that does something useful and with a nice maybe user interface. Um, that way you can share it with your colleagues and